Welcome everybody to my final part of my presentation where I'll be discussing Icmp. Please note that my student number is 104946665. Let's begin. Icmp is an internet control message protocol which basically does the following. The first thing is that it is used by network devices such as routers to generate error messages to the source IP address when network problems prevent delivery of IP packets. The second thing to note is that it is a network. Icmp is a TCP/IP network layer protocol that provides troubleshooting, control, and error messages services. It is most frequently used in operating systems for networked computers where it transmits error messages. The third thing to note is that Icmp is categorized as a layer 3 protocol in the OSI model, though in my opinion is that it does not meet the definition of a network layer protocol. This is because it does not provide addressing or packet routing, since it uses IP version 4 for this. So all it does is that it sends information from one node to another node, like transport protocol. The fourth thing is that it is connectionless, since it does not require packets to handshake before establishing a connection. This is unlike the TCP/IP, which requires a handshake to be established. The fifth thing to note is that Icmp has no ports, but only types and codes. It is also used in the Icmp flood attack, commonly known as the denial of service (DOS) attack, in which an attacker takes down a victim's computer or server by overwhelming it with Icmp echo requests, also known as pings. The last thing is that Icmp has message types from 0 to 254, but the ones which are commonly used or which are common to us are type 0, 3, 8, and 11, 0 being the echo reply, 8 being the echo request, 3 stands for destination unreachable, while 11 stands for time exceeded. The other thing is that Icmp packet has an 8-byte header that is containing 3 things: the major type that identifies the Icmp message, the minor code that contains more information about the type field, and the checksum that helps detect errors involved during transmission. Icmp messages also contain the entire IP header from the original message, so that the end system knows which packet failed. So now we'll go to a demonstration and see how it works. Let me open a command prompt. Let me first of all find out the IP address of our machine, including the virtual machines. We do this using a command called ipconfig. Yeah, we've gotten a reply. As you can see, this one is Ethernet adapter, and this is the IP address, and that is the subnet mask. We also have a wireless, which I've connected right now, this is the IP address, and this is the subnet mask. This is class A, while this one is class B. If I want to find if either of them is up and running, let me just try to ping that. Let's ping the first one for the Ethernet, which is basically 169.254.142.176. Let's ping that and see if the host is up. As you can see, we are getting replies. Yeah, these are the replies we've gotten. Four packets have been sent and 4 have been received. So we've lost nothing. We have 0% loss as indicated here. The round trip took less than 1 millisecond, and the time to leave before the router drops it is 128 milliseconds. And we can also check if also the Wi-Fi is up. Let's just ping that again. Ping 10.65. 10.65.55.140. Yeah, we're also getting replies from it. That means also the service is up and running. If it wasn't running, maybe we'll have gotten some error messages, including the type field or the reply that something is wrong with it. If we go to Wireshark, let me open Wireshark. You see already data is being captured from our ping requests. Yeah, you can see here. Yeah, this is the request that we made. So let me just open that nicely. Yeah. So the source IP of our machine is this one. The destination where we want to ping is still the same machine because we are pinging our own machine to see if the internet is up and running. The protocol in use is Icmp. The length was 64 bytes. We got an echo. That means we got some replies. And these are basically the other fields such as time to leave before a router drops it. So this is the request and this is the reply. The reply, the time taken from the request to the reply is this one here. And something to note is that we are using IV protocol version 4. The source IP is this one. The destination IP is that one also. I think I've covered everything. Yeah, thank you for your time. Thank you for listening to me, and God bless you.